When dealing with organic chemistry and hydrocarbons and naming, you're actually going to deal with the functional groups. And functional groups are groups that actually differentiate within hydrocarbons and actually give hydrocarbons unique properties. They are things besides hydrogen and carbon that you actually might add within a chain of hydrocarbons. That makes the branch of organic chemistry a lot larger. So there's several of them, and these are the ones you're probably going to see most often. The first one being a halocarbon, halo reminding us of what halogens, so we're dealing with halogens in this. And whenever I write R, that means I'm dealing with a backbone of carbon in some sense. So if we have like our parent group of R bonded to a halogen, that is the typical general formula for it. Here's an example of it. Notice we have the halogens up here, and then we're going to name this 1-bromo, 3-chloro, 2-fluorobutane, butane being 4 carbons in its backbone. And notice these are in alphabetical order. B, C, and F, even though the numbers are not the right way. Make sure your alphabetical order is always first. And a practical use might be for halocarbons is Teflon. Teflon's a halocarbon. The stuff that you use to make the nonstick pans or something along those lines, Teflon is actually used quite often. Alcohol is another functional group that you'll see. Alcohol is a parent group bonded to an OH. It could be anywhere. It doesn't have to be on the end of the chain. It could be anywhere within that chain. Here's an example of what an alcohol would look like. This is ethanol. And the way you name alcohols is that you put an OL as a suffix. So you're going to call it ethanol, showing that there's an alcohol there. And different types, and ethanol is actually used for drinking. Drinking alcohol is actually, we drink ethanol in alcoholic beverages. Methanol is the alcohol we use to swab our wounds. So methanol having 1 carbon, CH2OH is used as like a cleanser for cuts and things. Ethers have an oxygen in the center, so no hydrogen around it, just oxygen. There's a parent group on one side, parent group on the other, and there's oxygen kind of in the middle. Here is one example of an ester, an ether. And so this, notice there's a carbon chain on one side, carbon chain on the other, and oxygen in the center. And the way we say that it's an ether is you name the parent chains on either side ending with ether. So this will be propyl ethyl ether, saying that on one side's a purple group, on the other side's an ethyl group, and then it's an ether, meaning oxygen's in the center of those two. And this is actually used as an anesthetic. Back in the day, actually not so much anymore, but back in the day it was used a lot for an anesthesia to actually help numb the pains for surgeries. Amines are another functional group you'll see, and that's NH2 attached to a carbon group. This is a cyclical hexane, a cyclohexane attached to its amine group. And so an easy way to name this is it's a cyclohexyl group, and their amine is our functional group in this case, our parent group in this case. So we're going to make sure we have that in there. Cyclohexylamine. This shows that this is the functional group, and this is the actual parent thing, the amine. This is actually used as a pesticide. Ammonia is actually not is a poisonous material for most animals and bugs, so this would be used as a typical pesticide. Another one we have are aldehydes. You might be familiar with aldehydes. Aldehydes have a parent group in the C carbon double bonded to an oxygen at the very end of the chain. So this will always occur at the very end of the chain. We only have one side that has a parent group. Here's an example right here of an aldehyde. This is an ethanal. This is called ethanal because there's 2 carbons, meaning that's F. And al, the AL, is indicating that's an aldehyde. So that's our suffix for dealing with aldehydes. Al, so this is ethanal. Formaldehyde is actually methanal when it has just 1 carbon attached to it. So that's another thing. And this is actually used in glues. Glues use ethanals. Another one we might come across is ketones. Ketones is when you have, actually it's the same thing as an aldehyde, but because aldehydes are 3 end, that makes it unique. Ketones are C double bonded to an O in like the middle of a chain. So you have a chain on one side, a chain on the other, and carbon double bonded to oxygen somewhere along in the middle. Here's an example of a ketone. Notice we have 2 parent chains on the outside with a carbon in the middle bonded to an oxygen. And we're going to show that where that double bonded oxygen is located in our number. So it's going to be 2-propanone. So 2 is telling us that it's the double bonded oxygen is in the second carbon. And there are 3 carbons, making it prop, and -one is a suffix we're going to use when dealing with ketones. This is actually used in nail polish remover. One of the last ones is carboxylic acid. Carboxylic acid is one of our only acidic groups, meaning that we have an H will readily fall off and it will act as an acid. So it's a functional group with COOH bonded at the very end. This will always be found at the very end of the functional group of with the parent carbon chain in the front. And here's an example of a carboxylic acid. Notice this is what makes it a carboxylic acid. This is the hydrogen that will fall off and make it an acid. This is ethanoic acid, eth meaning 2 carbons. Anoic acid is a suffix for carboxylic acids, anoic acid. And this is actually used in vinegar. Another common name for it is acetic acid. You might know of it as acetic acid when you're dealing with acid-base units. And the last one that we're going to talk about today are esters. Esters is when you have a carboxylic group, but in the middle. So it's carboxylic acids on the very end, but an ester group is actually in the middle. So we have our parent chains of carbon on either side, and then carbon double bonded to an oxygen and single bonded to another oxygen in the middle. Or it doesn't have to be in the middle, but not on the end of the chain. Here's an example of this. The way to name this is called ethyl butanoate. The O8 indicates that it is an ester. And then the way you name it is you have whatever's after the oxygen comes first. So this is the ethyl group. And butanoate is because there's 4 carbons before that, but being the prefix 4. So this would be ethyl butanoate. And this actually, esters are really scented. They are used in making artificial flavorings. And so this is actually the scent of pineapple. Ethyl butanoate is actually a pineapple scent. So these are the main functional groups you'll probably see and be forced to name actually when you're doing chemistry, organic chemistry. Unfortunately, you're going to have to, there's really a hard way to, there's no really good way to actually give you a trick to remembering them. It's a lot of memorization, which is unfortunate, but hopefully this will help you understand and help you dissect functional groups.